The sweep feature is one of the basic features available in SolidWorks that allows you to generate solid geometry. It can be used to create simple geometry as well as complex shapes. A sweep is composed of two items, a profile and a path. The profile controls the shape of the sweep, while the path controls its direction. Take a look at this angled cylinder. This was created using a simple sweep, with the circle as the profile and an angled line as the path. By making the path a bit more complex, you can see a sweep allows you to create shapes you wouldn't be able to create using simpler features such as the extrude or revolve. To take the sweep feature to the next level of complexity, you can add what are called guide curves. These curves control the size of the profile as it's swept along the path. Here, for instance, the elliptical profile varies in size along the path because it's controlled by a guide curve. Although only one guide curve is used here, you can have as many guide curves as you need. We'll be taking a look at how to use sweeps in the next few lessons. We'll begin with a basic sweep that incorporates some advanced options such as guide curves and end tangency as we go along. The basic sweep requires two elements, a profile and a path. A profile is a sketch that defines the cross-sectional shape of the sweep. In this example, the profile sketch is a circle. A path is used to control the direction of the profile. In this example, a sketch is used to control the path. We'll see later that a path can be something other than a sketch, but for this basic example, a sketch is used to define the path. There are some important differences between sweeps and the basic extrude and revolve features you may be more familiar with. Let's take a look at these differences by creating a basic sweep from scratch. When you begin a new part, the only available icons on the Features toolbar are the Extrude and Revolve features. The Sweep icon is not available. Remember that a sweep requires two elements, a profile and a path. SolidWorks knows that at the moment I have neither, so it wouldn't make sense for the Sweep icon to be available at this point. To activate the sweep icon, you first have to create both a profile and a path. Let's concentrate first on creating the sweep profile. I'll begin a new sketch on the front plane and sketch a circle. As with other features, it's not necessary to dimension the sketch before completing the feature. All I need for the sweep profile is a circle, so I'll exit the sketch. Next, we'll create the sweep path. For this, I'll begin a new sketch on the top plane. It's very important that you understand we are now working on a new sketch that's completely separate from the first sketch. In this new sketch, I'll create a line and a tangent arc to serve as our path. And put in some dimensions. Notice that even at this point, although the path is essentially complete, the sweep icon is still not active on the Features toolbar. To be able to use the sweep feature, I must have a profile sketch and a path sketch, and I must exit out of all sketches. In other words, I cannot be in edit sketch mode. I'll exit the sketch, and now you see the sweep icon is available. I'll click on it, and we'll see the Sweep Property Manager appear. At the top of the Property Manager, you will see two selection boxes. The first is where you select the sketch you wish to use as a profile, and the second is where you select a sketch to be used as the path. If you forget which goes where, simply hold your pointer over the blank section box and a tooltip will appear telling you what is required. You may also notice that one of these selection boxes may already contain a sketch, although you did not select one. This will happen if you select the sweep icon immediately after exiting a sketch. In this case, I had just exited the path sketch when I clicked the sweep icon, so SolidWorks placed the sketch into the path selection box. If you're wondering how SolidWorks knew this was the path sketch and not the profile sketch, it assumes a sketch containing an open contour will be used for a path, while a closed contour will be used for a profile. Since the path sketch is already selected, all I have to do is select the profile sketch. I can do that by clicking on the circle itself, or by selecting the sketch from the Feature Manager tree. To be sure the correct sketches are selected, Solidworks will color code them for you as you indicated in the Property Manager. The blue sketch is your profile, while the pink sketch is your path. In case you made a mistake with your selections, you can easily remove an item from the selection window using one of several methods. The easiest is to simply click the selected sketch in the graphics area. This works like a toggle switch. One click selects the sketch, another deselects the sketch. You can also right-click the selection box and pick Clear Selections. And you can right-click in the box and press Delete on your keyboard. Any of these methods will work. As you make your selections, be sure the appropriate selection box is active. As with other selection boxes in SolidWorks, you know which one is active because it is highlighted. With the sweep feature, once you select a profile, the path selection box is automatically activated so you can quickly make your next selection. With both the profile and path sketches selected, I'll click OK and the simple sweep is complete. A sweep profile must be created as a sketch. A path, however, can be one of several items. In this lesson, we'll take a look at the various items that can be used as sweep paths. The simplest type of path is a 2D sketch. The sketch can be an open profile, as you see here, or a closed profile like a circle. It can be useful in some cases to have a path that is not attached to the profile. Here, for example, a sweep can be created despite the distance between the profile and path. In addition to using sketches as paths, you can also use existing model edges. Here, for instance, the circle is swept along the edge of the block. If you have multiple contours in your profile sketch, they will each be swept along the path. Here, for example, each of the circles will be swept along the edge of the block. When you create a sweep, you will notice that the path selection box in the Property Manager is limited to a single item. If you wish to sweep a profile along several edges, you can do so by using Smart Selection. Here I wish to keep the rectangular sketch around every edge of the solid body. I'll launch the sweep command and select the rectangle as the sweep profile. Instead of selecting the edge as the path, I'll right-click on the edge and choose Selection Manager. With the Selection Manager active, I'll use the Select Group option and begin clicking on the edge segments I would like to include in the sweep. When I'm done selecting edge segments, I'll click OK, and the items I choose will become this sweep path. In addition to using sketches and model edges as sweep paths, you can also use curves, such as projected curves, curves through free points, and curves through reference points as you see here. The circular sketch here will be used as the sweep profile, while the curve will be used as the path. By knowing the various types of entities that can be used as sweep paths, you can save time by avoiding the creation of sketches if they aren't necessary. You will also be able to apply sweeps in more scenarios, such as the modeling of tubing and wiring. Guide curves used with the sweep feature allow you to vary the size of the profile as it is swept along its path. Let's take a look at a simple example of this. Here I have two sketches, a circle sketched on the top plane and a vertical line sketched on the front plane. Before I click the sweep icon, I want to create a third sketch to be used as a guide curve. I'll start a new sketch on the front plane. The sketch will be a 3-point arc. When you sketch a guide curve, it must be attached to the profile somehow. In other words, I cannot have a guide curve like this. The sketch has to touch the profile like this. To ensure the curve is attached to the profile, you can use a special geometric relation called pierce. To use the pierce relation, keep one important item in mind. The pierce relation is only available between a point and a curve. If you select 2 points, the pierce relation will not be available. You must select a point and a curve such as a sketch entity. Here I'll select the endpoint of the arc, the point, and the circle from the profile sketch, the curve. You can see the Pierce relation appear in the Property Manager. I'll select it, and now I'm sure the point is exactly on the circle. Before I exit the guide curve sketch, there are some things you should know about the length of the guide curve and path. Essentially, the sweep will only go as far as the shortest curve, whether it's the path or the guide curve. If you have a situation where you're using multiple guide curves, the shortest one will control the length of the sweep. In this case, I want the sweep to be as long as the path. So to make sure the guide curve is at least as long as the path, I will create a horizontal relation between the endpoint of the arc and the endpoint of the path. Although it's not necessary, I'll add a couple of dimensions to control the guide curve. I'll dimension the path to establish the size of the sweep at the top, and to control the curvature of the arc, I'll dimension its radius. With the guide curve fully defined, I'll exit the sketch and click the sweep icon. I'll select the profile and the path. To use the guide curve, I'll expand the guide curve section and select the other sketch. You can immediately see the preview update. I'll click OK, and the sweep with the guide curve is complete. Before we conclude this lesson, I want to point out an important detail when working with guide curves. Remember, the purpose of guide curves is to change the size of the profile as it is swept along a path. Let me edit the profile sketch. Notice the circle is not dimensioned. If I add a dimension to the circle, as soon as I exit the sketch, the sweep will not work. Consider that when the circle has a diameter defined with a dimension, the guide curve cannot change this diameter as it's swept along the path. In most cases, fully defining your profile sketch defeats the purpose of using guide curves. One more thing I want to mention. In this example, I sketched the profile before sketching the path or guide curve. If you sketch the path or guide curves first, you can use them as guidelines as you create the profile. If you intend to use guide curves, I highly recommend you sketch them before sketching your profile. This will help you avoid using dimensions and relations on your profile that may accidentally restrict your use of guide curves, as we just saw. This is only a recommendation, but one that can help you out of trouble when using guide curves. By using more than one guide curve, you can create very complex shapes. You can also run into problems that will cause your sweep to fail. Most failures are a result of profiles that are too rigid. Let's take a look at an example. Here I have a part with 4 sketches, a vertical line to be used as a path, 2 separate sketches to be used as guide curves, and a circle to be used as the profile for a sweep. I'll click the sweep icon and select the profile and path. Next, I'll select the first guide curve, and the preview of the resulting geometry appears. Next, I'll select the second guide curve, and the preview disappears entirely. Whenever a preview disappears, you can be sure there's a problem. If I click OK, I get an error message and the sweep fails. To be certain there isn't a problem with the second guide curve, let me deselect the first guide curve. As you can see by the preview, the second guide curve appears to be fine. So what is the problem with using both guide curves? Well, the problem is that the profile sketch, a simple circle, is too rigid to take advantage of both guide curves. Notice what the guide curves are doing here is controlling the radius of the circle. At a point about halfway up the path, one guide curve is forcing the radius of the circle to be very small, while at the same time, the other guide curve is trying to make the radius very large. This poses a conflict since the circle can only have one radius. In fact, if the guide curves were to deform the profile, you would end up with an ellipse, not a circle. To correct this problem, you simply have to make a change to the profile sketch. You have to give it the freedom to be able to follow both guide curves. And in this case, changing the profile from a circle to an ellipse will do the trick. As you add more guide curves, you will likely have to go to an even more unrestricted profile sketch, a spline. In this example, a third guide curve has been added. In order for the profile to follow all three curves, a spline was used. When you use the sweep feature, there are several options available that will affect the resulting geometry. These options include the use of guide curves, twist, tangency, and orientation. In this lesson, we'll take a look at the use of different orientation types. Although the majority of the time you will likely be using the default orientation known as follow path, it's helpful to understand the effect of using the other orientations. Let's begin by comparing these two individual sweep features. Although they appear quite different, they were actually created using identical profiles and paths. The difference in the resulting geometry is due to the behavior of the profiles as they are swept along their paths. In the first example, the orientation of the circular profile follows the path. As the path transitions from a straight line to a curve, the profile changes orientation to follow. This is the default behavior of a sweep and is referred to as follow path. The second example, you can see that as the path transitions from a straight line to a curve, the profile orientation does not change direction with the path. It maintains the same direction as the original sketch plane of the profile. This behavior is called keep normal constant. To make this clear, take a look at a cross-section view. Notice that at any point along the path, the cross-section is always the same. If I edit this sweep feature, you can see in the options section, there's a list of available orientation and twist types. Currently, the keep normal constant option is selected. If I change this to the default follow path setting and click OK, you see the result is now identical to the first sweep. Once you've experimented a couple of times with the follow path and keep normal constant options, you'll quickly understand the difference between them, and you'll be able to decide rather easily when to use each one. Unfortunately, the same cannot be said about the next available options. For many users, the settings called follow path and first guide curve and follow first and second guide curves simply become something to try if nothing else seems to work. Let me try to explain the idea behind these settings and hopefully make them less mysterious and maybe even useful for you. I'll start with this simple sweep. It's a triangular profile swept along a straight line. I'll edit this sweep. And use this sketch as a guide curve. Notice that although the triangular profile now follows the guide curve, the overall triangular shape is not twisted. That is, the edge that was horizontal to begin with remains horizontal at the end of the sweep. Now let's edit the sweep again, and this time change the orientation to follow path and first guide curve. Now you can see that the profile not only follows the guide curve, but it has twisted. The edge that used to be horizontal no longer is. So why is that? And how is the twist angle defined? Let's edit the sweep once again and change the orientation back to follow path. To help explain this, I have two sketches I'll show, as well as a couple of reference dimensions. The lines I have here connect the path to the guide curve. You can see that in the initial profile, the angle between the line and the horizontal edge is 90 degrees. At the end of the sweep, you see the angle has changed quite a bit. Now let's change the orientation to follow path and first guide curve. Notice the angle at the end face of the sweep is now the same as it was in the beginning. By selecting Follow Path and First Guide Curve, you're instructing Solidworks to twist the profile as it's swept along so this angle stays the same. This may not seem very important to you at the moment, but you would be surprised at how many times users will add guide curve after guide curve in an attempt to end with this exact result, simply because they don't understand how the setting works. If you understand the principle behind the setting, the same thing applies to follow first and second guide curves, except this line is defined by connecting the first guide curve to a second guide curve instead of the path. In addition to controlling the behavior of a sweep profile with guide curves, you can also have a profile twist as it swept along a path. Let's take a look at how this is done. I already have two sketches in place, so I can click the sweep icon to begin. I'll select the profile and path, and a preview of the simple sweep appears. In the Property Manager, I'll expand the Options section and select Twist Along Path from the Orientation list. The characteristics of the twisting behavior can be specified in number of turns, degrees, or radians. I'll select Turns for this example. You can see the resulting geometry is drastically different. This is a useful feature to be familiar with, especially if it's going to save you from having to create complex guide curves. Take this model for instance. Creating this without the use of the twist can be quite a challenge. The sweep path used here is a circle, and the twisting is taken care of through the use of the Twist Along Path option. The Twist Along Path option can also be combined with Keep Normal Constant to further control the behavior of the sweep. Take a look at this part. This is a sweep using a rectangular profile, an arc as a path, and the Twist Along Path orientation setting. If I create a section view that runs parallel to the profile sketch plane, you can see the intermediate profiles are quite different in shape than the rectangular profile. Let me edit the sweep and enable the Twist Along Path with Normal Constant option. This shape will take a second for Solidworks to generate, but it's normal as your geometry gets more and more complex for features to take longer to rebuild. Take another look at that section view. Notice this time the intermediate profiles are the exact same shape as the original. Although our focus thus far has been on creating geometry with sweeps, you also have the option of removing geometry by using the Cut Sweep feature. The sketch requirements for the cut sweep are the same as those for a regular sweep. You need a profile and a path. The profile is defined in a sketch, while the path can be a sketch, a curve, or an existing model edge. In this example, I want to trim away the sharp edge of this part to create a nicer looking finish. I already have a sketch in place to be used as my sweep profile. It was created on a plane defined as normal to this edge of the model. The Cut Sweep feature is not normally on your Features toolbar. You will have to either add it to your toolbar or access it from the drop-down menu under Insert, Cut, Sweep. Once activated, the Property Manager for the Cut Sweep should look familiar. It's identical to that of the regular sweep. I'll select the profile and the path. Notice a preview shows up, but it only goes as far as the first segment of the model edge. Since the edge is made up of tangent segments, I can use the tangent propagation setting in the Options section of the Property Manager to get the cut to propagate along the entire edge. If your preview does not update, you can simply deselect and reselect the path. At this point, I can click OK and the cut sweep is complete. Before we continue, I want to return to the Cut Sweep Property Manager and point out a setting that is very important in situations like this one. The setting is called Align with End Faces, and it's found in the Options section of both regular and cut sweeps. I'll uncheck this setting and click OK so we can examine the results. Notice the cut sweep only goes as far as the path I selected. In most situations, you don't want to be left with extra material like this. By default, Solidworks will extend the sweep up to the next available face. However, this only happens if the Align with End Faces option is enabled.